function spectrum allocation manager for top-level frequency management. And to start with that, I select the spectrum allocation manager. I log in to it with full read and write permissions, because we are going to create allocations and modify them. The initial setup and installation of the Spectrum Allocation Manager will give the ITU Region 1, Region 2, and Region 3 a table of frequency allocations. So in the table, clicking on any of the bands here will inform us of which services that are assigned on primary and secondary basis. Going to band notation editor, we can read all the footnotes that are valid for this particular band. Some initial manipulations here can be done in order to produce the desired print results. So let's call this ITU Region 1. We'll make this as a colorful bar chart with the bands in color. That is, we put the legends on. We can select to print the footnotes and any other standards that may be introduced as referenced to each band, but I will not do that. And let's make this into an A3 size printout. And have a preview of that. So this is what that printout will look like. And it can be changed to print on several pages or even more compact than this, but it will be quite a busy chart. Now, the normal procedure when working with the Spectrum Allocation Manager is perhaps not just use it for the ITU table of frequency allocations. You would rather use it to create your own plans. And that can be done based on the ITU plans, for instance. It can be copied, and then you can continue to work with that plan to modify it into a national plan or a military table of frequency allocations. Right now, we're going to work with this in a slightly different way. I want to prepare a table of frequency allocations for 2 to 12 megahertz, selecting the fixed service and mobile service allocations. And there's a particular reason for that, because those are typically used for military purposes. And in the continuation of this demonstration, we will talk about military spectrum management. So to quickly create such a plan, I add filters. I will select 2 to 12 megahertz, service fixed, and I call this filter then obviously fixed 2 to 12 megahertz. And another one that will be a mobile, mobile 2 to 12 megahertz. This can be refined, and actually having a little more time, we should do that because there are a few of the mobile and fixed allocations that are shared with other services where we really should not assign frequencies. But this shows the general procedure. Selecting the filters here, I can apply them and filter mode match all or match any. We will have match any here because we will have the logical OR function between the filters. So there they are in the list to the left. I can create this as a new plan, and I call this ITU region 1 2 to 12 megahertz fixed and mobile. Just as before, we can have a quick graphical overview of the plan by applying the print function. So this is what it will look like, and as can be seen here, it is shared with there are many bands here that are shared with fixed and mobile services. So it is possible then to continue with detailing these allocations into regulations for each band. Perhaps we have a for this band we wish to assign some special standard or regulation, and those can be put in there by entering available standards in the table of available standards. It can be subdivided also, the 3.5 to 3.8 megahertz subdivided into smaller bands where various regulations may apply. But we will not do that. Instead, we will make this into to continue with the example. We will prepare a channel plan or allotment of frequencies that subsequently will be used by the assignment process for the military radio networks. So marking all of these and right-click on them using the create allotment from band function will allow me to create the list of frequencies. In this case, it is typical that we will apply this plan for single sideband transmitters, and for that purpose we define this plan for the carrier frequency or the suppressed carrier frequency, not the assigned frequency. The difference between the assigned frequency and the reference frequency for upper sideband transmission is 1.5 kilohertz. We'll use 3 kilohertz channel separation. We also need to put in a consideration of the bandwidth on each frequency, and we'll put in 3 kilohertz because this becomes important when operating close to the band limits. We are not allowed to operate outside the band limits. The full bandwidth has to be within the band limits. Here it is possible to make a random selection and select a certain number of frequencies also if desired, but now we will use each and every frequency available in these allocations. So we use continuous. The channel arrangements here are not really applicable to HF, but if this instead was a microwave link allotment that we are creating, we may put in requirements for alternated polarization, for instance, on every other frequency, or other alternating polarization on the same frequency of the allotment. But we'll use the polarization independent channel arrangement for this HF allotment. Pressing next has created the allotment, and I will call this 2 to 12 megahertz fixed and mobile. Let's put in some other 3 kilohertz for the separation there. Here it is also possible to define compatibility, which classes of stations that are allowed to use this allotment, or the maximum radiated power. So let's put in maximum radiated power, say 30 dB watt, 1 kilowatt, and designation of emission and so on. So all kinds of additional administrative information can be put in here. So pressing OK saves this allotment in the SAM database. Going to the allotments selector here to manage the allotments, we can see that this has been created. Right now this is the only one that exists in my database. In normal operation this would be a much longer list. Now the spectrum allocation manager can operate standalone like this, and also communicate naturally with other users operating the SAM tool, and they will then be able to handle frequency allocations and allotments. To make use of the allotments for the continued spectrum management process using WRAP, we can communicate with the WRAP software, and the continued work will then be to assign frequencies to radio networks and perform interference analysis, perform coverage analysis, and all kinds of technical work. So I will export this to my WRAP database. I can select several databases, and I want to put it in my working database. Press OK to connect to the database, and then this database is not free to write in. I have to log in. So now I'm logging in to the other database that WRAP, the technical analysis software, is connected to. And now I am logged in. I want to export this database. No, not data. Export this allotment there. So I export. And there it is. It works the other way around also. I can import from the WRAP database to the SAM database. I close there and I close there. So to quickly recapitulate what we have done, we have created an HF table of frequency allocations for 2 to 12 megahertz fixed and mobile services. So it appears here. We have used this table of allocations to create an allotment. I did it the quick way of automatically entering the lower and upper frequency of each sub allocation. This can also be done individually here for each sub allocation. Here, this did not appear before because I did not have any allotments in my SAM database before, but now I do. Existing allotments can be used as blocking lists and the purpose of that is if we consider an already prepared allotment to be an exclusive allotment, it is not supposed to be used again. We can check it, and the frequencies of that allotment will not be used when we create the new one. So that completes this very quick run through of the Spectrum Allocation Manager.